Now that we have an overview of the processes that make up evolution, we asked Professor Donoghue, what evidence do scientists cite in support of this theory?
We can directly observe evolution in the form of antibiotic resistance in bacteria and the resistance amongst insects of pesticides, for instance. That's something that we can observe on short time scales. But over the longest of time scales, we also see evidence in the fossil record of the timing of appearance of different grades of organisms. So early in Earth history, in the sedimentary rocks representative of that time, we only find fossils of bacterial grade organisms. Then we see fossils of more complex organisms like eukaryotes, so single cell organisms with nuclei appear in the fossil record sometime later, and we don't see multicellular organisms until a good deal later, maybe a billion years after that. But there are, again, many other sources of evidence. There's anatomical evidence. If we look at the comparative anatomy of humans to horses to penguins, we're all based on the same sort of plan. We have similar sets of bones which are arranged in similar ways, and those bones are identified as homologs. They're inherited from bones that were present in the last common ancestor that we share, betraying the fact that we're all descended from the same ancestors going back through time. And we can build evolutionary trees from that anatomical evidence based on the shared distributions of organs or features of our skeletons. And that prediction has effectively been tested by an entirely separate line of evidence, and that is molecular biology. If we look at sequences of DNA, we can recognize that there are genes which are inherited from the last universal common ancestor and from common ancestors all the way up to the nearest relatives of humans, and we can recognize the same genes in the genomes of their living descendants. And if we analyze those to build grand kind of genealogies, we come up with more or less the same evolutionary trees that were based previously on anatomical evidence. If we combine evidence from the fossil record with molecular data, we can work out the rate of evolution in a kind of a speed equals distance over time type of equation, and we can calibrate the grand genealogy of the tree of life to a geological time.
Well, according to this perspective, we could ask, does evolution have a direction? I mean, if we look in the fossil record and see little single-cell organisms floating around in the earliest periods, and then much later on we find larger ones like dinosaurs, and then later on mammals and humans, perhaps that shows a direction. Is there some larger purpose to this arguably never-ending evolution of species?
The real trend that people are always trying to reach for is this sense of life becoming more complex over time, and it's true within the fossil record that in the earliest rocks we just find very simple bacterial grade organisms. In more recent geological deposits we find obviously a greater diversity of organisms, but the bacterial grade organisms are still there. It's not like life has gone from simple to complex. It's just the range of variation has increased over time. And it can only change in one direction because you can't get simpler than the simplest organism. All you can do is become more complex than the most complex organism, perhaps. And so what we see is an increase in the range of variation in terms of the complexity of organisms. But there's no sense of improvement. There are lots of organisms that have descended from complex ancestors to become very simple descendants, particularly lots of groups of parasites that make a very successful living exploiting the complexity of their hosts, even though they're descended from very complex ancestors themselves.